So what I want to talk about are what are called corner points. This is something, if you've been working through the activity 7.2, there's some problems about corner points, but I want to talk about them explicitly here because they're super important. I want to make sure we all understand how to find them and so forth, since we'll have to use them next week when we solve linear programming problems. So this is all about corner points. And so let me tell you what those are. Corner points are points where two lines intersect on the boundary of the feasible set. So if you remember from yesterday, when we graph our system of inequalities, I get a solution set where all my inequalities overlap. We called that solution set the feasibility set. And so the corner points are where lines are intersecting on the boundary of that feasibility set. So maybe I have a bunch of lines that I graphed for my inequalities, like so. And maybe the shaded triangle is my feasibility set. So this is my solution set for some system of inequalities. And the corner points are exactly where the lines are intersecting, touching the shaded part. So like here, there are 3 corner points. They're basically the points that make up the corners of the feasibility set. Hence why we call them corner points. So it turns out we're going to be interested in being able to find the coordinates of corner points. Of course, this is some random example, so we can't find these coordinates. But let's do a real example where we have to find the coordinates of the corner points. And we'll sort of see how to deal with that. This is something we'll have to be able to do to solve a linear programming problem. Okay, so let's take a system of inequalities as an example. I think I'm going to take this system of inequalities. X less than or equal to 2, y less than or equal to 3x plus 1, and y greater than or equal to -1/2 x plus 2. So we'll take these 3 inequalities. And let's go ahead and graph the system of inequalities. So this will be a bit of a refresher from yesterday, but then we're going to take one step further and figure out what the corner points should be. So here are my coordinate axes. Put in some tick marks. All right, and so let's go ahead and graph this. So if I do this first guy in red, it's x less than or equal to 2. I know I have to graph the line x equals 2. It's a vertical line through x equals 2. And since I'm doing x less than or equal to 2, I think I want to draw this graph a little bigger. So let me, apologies here, let me just redraw this a little, make the tick marks a little more spaced out to make the picture a little clearer. 1, 2. Okay, so we draw on the x equals 2 vertical line. And then since I'm doing x is less than or equal to 2, I have to shade everything to the left of that red line. So I'm shading to the left of that red vertical line through x equals 2. Okay, next I have to graph this y is less than or equal to 3x plus 1. So I have to graph the line y equals 3x plus 1. So that's a y-intercept of 1 and a slope of 3. And so maybe it's like this. Something like this. And then the question is, where do I shade? And it turns out if I test a point, I'll find that I'm actually going to shade underneath this point, this purple line. So if you remember how to test a point, I just take any point not on the line, I plug it into the inequality, and I see if it's true or false. 0, 0 is not on the line. So if I put in 0, 0, I'll get 0 is less than or equal to 1. That is a true statement. And so I'm going to shade on this side of the line because that's where 0, 0 is. So I'm going to shade underneath the purple line. So far we're overlapping sort of in between the red and the purple. And now I drew my graph bigger, and now maybe I drew it a little too big, but that's okay. We'll see why I said that in a second. Lastly, we have this other line. This y is greater than or equal to negative 1/2 x plus 2. And I'm going to graph this. Y equals negative 1/2 x plus 2. That's a y-intercept of 2 and a slope of negative 1/2. So when I go to the right by 2, I go down by 1. So something like this. All right. And y is greater than, so if I test a point up here, it turns out up above the blue line is where I'm going to shade. Take any point and test it. So I shade above the blue line. And so I drew, now I regret how I drew this, but that's fine. I can redraw it in a second. Where they all three overlap is up here. This goes off. And I'm going to redraw it in a second to make something clear, which is this should actually close up and be a triangle, like so. So maybe, man, okay, my apologies. We're going to redraw it. And this time, we're going to see the triangle. So maybe I'm just going to do this. So forth. So I had a purple line like this. I had my red line. We'll just move our tick marks over. We had our red line, comes up and intersects it. And we have our blue line that does this. Okay, so my feasibility set is this triangle here. Now we can clearly see it's a triangle. And the question that we want to answer now is not only do we want to know what the feasibility set should be, we want to know what the coordinates of the corner points are. This is something we're going to have to do to solve linear programming problems in the next section. So I want to know what the corner points are. And so how many corner points are there? It's a triangle, so there are 3. There's one here, there's one here, and there's one here. And we're going to ignore my scale because I'm not a computer and I don't draw very good graphs. And so what I want to caution you on is the following. My caution is don't rely on your eyeballs, because they will lie to you. If you want to try and just guess what the coordinates should be from your picture, you're going to be in trouble a lot of the time. Because, for example, maybe this corner point, I could kind of guess just from inspecting the picture, it looks like it's maybe coordinates 2, 1, right? And maybe that's okay. But like, what about this guy? It's like between, the x coordinate is like between 0 and 1, and the y coordinate is like between 1 and 2. So what are the coordinates? It doesn't look like it's halfway between. It's like, I don't know, it's weird. I don't know what the coordinates of these are just by looking. And because I'm really bad at drawing this graph, I don't know what this coordinate is either. This one should be a little more obvious if I drew the graph well, which I did not do. But my point, so this further goes to my point of you don't want to rely, you don't want to trust yourself too much when it comes to looking for corner points. You don't want to guess just from your picture. So what we'd like is an exact way to definitely find the coordinates of a corner point, for sure, using math, so that we don't have to make any guesses. We can just solve it out and find the coordinates. And that's not so bad. In fact, you guys already know how to do this. If we think back to chapter 5, you might remember on one of the activities, when we started solving systems of equations, one of our methods introduced on an activity was solution by graphing. And so we might recall to solve a system of 2 equations, we can graph the equations. The solutions are intersection points if we do that. So when I graph the equations in a system of equations, if the lines intersect, that's a solution of the system of equations. And so I'm looking for an intersection point of two lines. So I'm really looking for a solution to a system of two equations. Which equations? Well, they're the equations that gave me the lines that are intersecting. So to find the corner points, we're going to solve the system of equations. That's all we're going to do. Just solve the system of two equations. So let me demonstrate on this example. We have our inequalities, which means we have our equations. So just to remind you which equations we have, I have x equals 2, y equals 3x plus 1, and y equals negative 1/2 x plus 2. Again, just changing the inequalities to equalities, these were the equations that we graphed to get the lines, just to get the lines. So let's say I wanted to find this corner point first. Yeah. What is this corner point? Well, what I'm going to do is ask, what are the lines that are intersecting at this point? There was the red line and the purple line. The red line had equation x equals 2, and the purple line had equation y equals 3x plus 1. So to get this corner point, I have to solve this system of equations because these two lines are intersecting at this point. So I just need to solve this system of equations. This one's pretty easy for us to solve because we already know x is 2. So it's like halfway done already. So I just need to plug in x equals 2 to find y. So let's just do that. This is like the substitution method, right? I'm going to substitute x equals 2 into this equation and solve for y. That would give me that y equals 3 times 2 is 6 plus 1 is 7. So it must be that the solution to this system of equations, hence the coordinates of this corner point, is x is 2 and y is 7. So 2 comma 7 gives me the coordinates of this corner point because 2 comma 7 solves this system of equations. Okay, so that's what we do. If I want to find the coordinates of the other ones, I do the same thing. This one really is just 1, 2. So we could either solve the system of equations or sort of, in this case, we could safely eyeball it. But I invite you to check this one. I will do this one right now on the board, though, this other weird one off to the side. So I'll give you this one as 1, 2. This one, let's solve. All right, let's do another example. So I have this corner point that I want to find. What are the two lines intersecting here? There's the blue line and the purple line. So I need to solve the following system. I need to solve the system. See, the blue line is y equals negative 1/2 x plus 2. And the purple line is y equals 3x plus 1. So I need to solve this system. Okay. And so there's sort of a hidden advantage here. If you solve everything out into slope-intercept form, then you already have y equals. And so this is like a perfect setup for substitution. We're going to substitute. So if I want to solve this, I'm going to substitute y equals negative 1/2 x plus 2 into this equation, i.e., I'm going to solve this equation. I'm going to have negative 1/2 x plus 2 equals 3x plus 1. And I'm just rewriting this y as this, just substituting this down here. You might hear someone else call this like setting the two equations equal to each other, which is technically correct. They're both equal to y. Both of these are equal to y, so I can set this equal to this. But it's really just substitution. So I don't know. I'm going to call it substitution, but you call it whatever you want. So I substitute this down here. I get this. I can now solve this for x. And I'll do that. What happens? Add a half x to both sides. So 2 equals 7/2 x plus 1. I guess I could just subtract 1 from both sides too. And just get 1 equals 7/2 x. So I think x is 2/7 if I divide by 7 and multiply by 2. So x is 2/7. So like, I don't know who would have looked at this graph with their eyes and thought, oh, that x coordinate is 2/7.